So you want to know why the Big Bang never happened? Well, that's a hell of a question, isn't it? And I have to tell you right from the start, I'm going to make you uncomfortable because what I'm about to share with you challenges something that most people think is settled science. But here's the thing about science. It's never really settled. It's always being tested, poked at, questioned. That's what makes it science. Now, before we get into this, let me be clear about something. I'm not here to tell you that the Big Bang theory is complete nonsense, far from it. The Big Bang is an incredibly successful theory. It's explained a tremendous amount of what we observe in the universe. But, and this is important, explaining things doesn't necessarily mean it's the right explanation. And lately, some very serious physicists have been noticing some very serious problems. Let me start with what the Big Bang theory actually says. Because most people get this wrong. They think the Big Bang was an explosion. You know, like a bomb going off in space. That's not it at all. The Big Bang theory says that about 13.8 billion years ago, the entire universe, all of space itself, was compressed into an incredibly hot, incredibly dense point. Not a point in space, mind you, but space itself. And then it began expanding. It's still expanding today. Now, how do we know this? Well, in the 1920s, a fellow named Edwin Hubble looked at distant galaxies and noticed something peculiar. Their light was shifted toward the red end of the spectrum. The farther away the galaxy, the more it was shifted. This redshift, as we call it, suggests these galaxies are moving away from us. And if everything's moving away from everything else, well, if you run the film backwards, everything must have been together at some point in the past. That's the basic idea. Then in 1964, two radio astronomers, Penzias and Wilson, were trying to get rid of an annoying static in their antenna. Turned out they couldn't get rid of it because it was coming from everywhere, the entire sky. What they'd stumbled onto was the cosmic microwave background radiation. This is light that's been traveling through space since about 380,000 years after the supposed Big Bang, when the universe cooled enough for atoms to form and light to travel freely. This radiation is exactly what the Big Bang theory predicted, a faint afterglow of that primordial heat, now cooled down to just a few degrees above absolute zero. So you can see why people believe in the Big Bang. We've got galaxies moving apart, we've got this radiation that looks exactly like it should if there was a hot early universe. We've got the abundances of light elements like hydrogen and helium that match what we'd expect from nuclear reactions in the early universe. It all fits together beautifully. But now let me tell you about the problems. And these aren't small problems. These are the kind of problems that make you wonder if maybe we're looking at things the wrong way. First problem, lithium. The Big Bang theory makes very specific predictions about how much lithium should have been created in the early universe. It's not a vague prediction, it's precise. 400 lithium atoms for every trillion hydrogen atoms. But when astronomers look at old stars, the oldest stars we can find, they don't see that much lithium. They see less than 1/10 of what the Big Bang predicts. Now you might say, well, maybe stars destroyed some of the lithium. But the problem is, the older the stars we look at, the less lithium we find. That's backwards from what you'd expect if stars were destroying it. This is what they call the lithium problem, and nobody's solved it. Second problem, the cosmic microwave background itself. Yes, it exists. Yes, it looks like blackbody radiation. But here's something interesting. It's too smooth. Let me explain what I mean. When you look at the CMB from one side of the sky and compare it to the other side, the temperature is the same to within 1 part in 100,000. These two regions of space are so far apart that light hasn't had enough time since the Big Bang to travel between them. So how did they know to be the same temperature? It's like having two pots of water on opposite ends of a kitchen, never touching, never connected, and finding out they're at exactly the same temperature. How does that happen? The standard answer is inflation. They say that in the first tiny fraction of a second after the Big Bang, the universe expanded faster than light, exponentially faster. This brought distant regions into contact. They evened out their temperature, and then whoosh, they got separated by this incredible expansion. But here's the thing. Inflation is not something we've observed. It's something we made up to fix the problem. And to make inflation work, you need this thing called an inflaton field, which is something else we've never observed. We're inventing invisible things to explain why our theory doesn't quite work. Third problem, dark matter and dark energy. The Big Bang theory, as originally conceived, predicted a universe made of ordinary matter, atoms, stars, Galaxies. But when we look at how galaxies rotate, they're spinning too fast. They should fly apart based on the visible matter we can see. So we invented dark matter, invisible matter that doesn't interact with light, to hold them together. We've been searching for dark matter particles for decades in incredibly sensitive experiments deep underground, and we haven't found them, not one. Then we discovered the universe's expansion is accelerating. This shouldn't happen. Gravity should be slowing it down. So we invented dark energy, a mysterious force pushing space apart. Put it all together and we now say the universe is 70% dark energy, 25% dark matter, and only 5% ordinary matter. The stuff we understand makes up 5% of the universe. Does this sound like a theory that's working well? Now, let me tell you about an alternative idea that some physicists are seriously considering. What if the Big Bang never happened? What if the universe has always existed in some form without a beginning? There's an old idea called the steady-state theory. Fred Hoyle proposed it in the 1940s. He said the universe is eternal. It's always expanding, but new matter is continuously being created to maintain a constant density. Most people think this theory was killed off by the discovery of the cosmic microwave background, but some physicists have revived a version of it. They call it quasi-steady-state cosmology. They say that the microwave background isn't leftover radiation from a Big Bang, but rather starlight that's been absorbed and re-emitted by tiny iron particles throughout space. Now, before you dismiss this, think about what I said earlier about the smoothness of the CMB. If it came from stars and particles rather than a singular event, that might actually explain why it's so uniform. You don't need inflation. You don't need this magical exponential expansion that we have no evidence for. There's another alternative based on something called plasma cosmology. This says that electromagnetic forces, not just gravity, play a major role in shaping the universe. In this view, the redshift we see in distant galaxies might not all be due to expansion. Some of it could be due to light losing energy as it travels through space over vast distances. This is called tired light. Now, I have to tell you, most physicists don't like tired light because we don't have a good mechanism for it, but we don't have a good mechanism for dark energy either, and we're comfortable with that. Here's something else to consider. The Big Bang theory requires the universe to have had a beginning, a singularity, a point where all the laws of physics break down. Density becomes infinite. Temperature becomes infinite. Our equations give us infinity, which in physics is usually a sign that something's gone wrong with your theory. Einstein's theory of general relativity, which is what we use to describe the Big Bang, predicts its own failure at this point. Some physicists think maybe the Big Bang wasn't the beginning at all. Maybe it was a bounce. Maybe the universe was contracting before, collapsed to an extremely small size, and then bounced back out into the expansion we see now. This is called the Big Bounce. Roger Penrose has proposed something similar, a cyclic universe that goes through repeated phases. Each cycle ends with the universe spreading out and cooling, but somehow, through quantum processes we don't fully understand, this triggers the start of a new cycle. Now, I want to be honest with you about something. These alternative theories have their own problems. Steady-state cosmology struggles to explain the abundance of light elements as well as the Big Bang does. Plasma cosmology hasn't made as many successful predictions. The cyclic models require exotic physics that we haven't confirmed. Every one of these alternatives asks you to accept something strange and unproven. But here's my point. So does the Big Bang. When you add up all the things we've had to invent to make the Big Bang work, inflation, inflaton fields, dark matter, dark energy, we're asking you to accept that 95% of the universe is made of things we've never detected. We're asking you to believe in a faster-than-light expansion for which we have no direct evidence. We're asking you to accept a beginning that breaks all our laws of physics. Maybe the right answer is that we don't know. Maybe we need to be more humble about what we claim to understand about the universe's origin and evolution. Let me tell you what I think is really going on here. I think we've fallen in love with a story. The Big Bang is a compelling narrative. The universe had a beginning, it's been evolving, it's heading toward some eventual fate. It fits nicely with many people's intuitions about how things should work. And when a theory is this successful at explaining things, we become reluctant to question it. We patch it with dark matter when it doesn't work. We add dark energy when we need it. We invoke inflation when we have to. But maybe we're like the astronomers before Copernicus, adding epicycles to make the Earth-centered model of the solar system work, when what we really needed was to change our fundamental assumptions. Does this mean the Big Bang definitely didn't happen? No, I'm not saying that. What I'm saying is that science requires us to question, to test, to look for flaws in our theories. And right now, there are significant flaws in the Big Bang theory. Whether those flaws mean the theory is fundamentally wrong or just incomplete, we don't know yet. The universe doesn't care what we think about it. It is what it is. Our job as scientists is to figure out what that is as accurately as we can with as much intellectual honesty as we can muster. And part of that honesty is admitting when we don't know something, when our theories are struggling, when we might need to consider alternatives. So when someone asks me, why did the Big Bang never happen? I say, well, maybe it did, maybe it didn't. What I can tell you is that our current understanding of cosmic origins is incomplete. We're missing something, whether that something is just a few details to fill in, or whether it's a fundamental reconceptualization of how the universe works. Time will tell. The wonderful thing about science is that it's self-correcting. If the Big Bang theory is wrong, eventually the evidence will bury it. New observations, better telescopes, more precise measurements, these will guide us toward the truth, whatever that turns out to be. It might take years, or decades, or even centuries, but we'll get there. In the meantime, I encourage you to think critically about everything you're told, even by scientists, even by people like me. Ask questions, demand evidence, understand the difference between what we've actually observed and what we've inferred or invented to make our observations fit together. The Big Bang might be right, it might be wrong, it might be partially right, but whatever the case, the pursuit of the answer, that's what science is all about, and that's something I know for sure.